In this next problem, we're going to graph a conic section using a rotation of axis. What we have is 4x squared minus 4xy plus y squared minus 8 root 5x minus 16 root 5y equals 0. We want to graph this equation. First thing we should do is compare it to the general form of a conic section, which is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. All we really want out of this is to know the values of a, b, and c, because the appropriate rotation is going to require that we solve the equation cotangent of 2 theta equals a minus c divided by b. That is, cotangent of 2 theta equals a is 4 minus c is 1 divided by b is negative 4. That gives me that the cotangent of 2 theta is negative 3/4. Now we could take the arc cotangent of both sides of the equation. The only problem is that's not going to give us an exact value for the angle theta. Therefore, we have to go a different route. The different route that we're going to go is as follows. Remember, our goal here, in order to find the appropriate rotation, is to determine sine of theta and cosine of theta. Well, it turns out that sine of theta, using your double angle formulas, is equal to the square root of 1 minus cosine of 2 theta over 2. And the cosine of theta equals the positive square root of 1 plus the cosine of 2 theta over 2. Well, I know the cotangent of 2 theta is negative 3/4. Therefore, it's pretty easy for me to figure out the cosine of 2 theta. Because the cotangent of 2 theta is negative 3/4, which is clearly less than 0, I know that 2 theta is going to be between 90 degrees and 180 degrees, because the cotangent, again, is negative. Since 2 theta is in the second quadrant, I know that the cosine is going to be negative as well, and the cosine of 2 theta is going to be negative 3/5. Basically, the way we get that is the fact that the cotangent of 2 theta is equal to negative 3 over 4, which is negative a over b. We use the fact that a squared plus b squared equals c squared. That would get us that c is 5, so that the cosine of 2 theta is equal to negative 3 over 5. Now that we know the cosine of 2 theta equals negative 3/5, we can use this fact to find the sine of theta and the cosine of theta. Let me slide this paper up, and then what we get is that the sine of theta is equal to the square root of 1 minus negative 3/5 over 2. That gives me that the sine of theta is equal to 1 minus negative 3/5 is 1 plus 3/5. That's going to be 8/5 divided by 2. 8/5 divided by 2 gives me 4/5 under the radical. So I have, eventually I'm going to get 2 root 5 over 5, because the square root of 4 is 2, so I have 2 over the square root of 5, and then I rationalize my denominator. Likewise, I need to get the cosine of theta. That's going to be 1 plus negative 3/5 divided by 2 under the radical. So I have 1 plus negative 3/5 is 1 minus 3/5. That's going to give me 2/5. So I have 2/5 divided by 2, which is the square root of 1/5. And if I rationalize my denominator, I get root 5 over 5. Now, what am I going to use this information for? I use this information in the formula for the rotation. Remember, x is going to equal x prime cosine of theta minus y prime sine of theta. So I have x prime cosine of theta is root 5 over 5 minus y prime sine of theta is 2 root 5 over 5. For simplicity's sake, factor out a root 5 over 5. So we have root 5 over 5 x prime minus 2y prime. Then y equals x prime sine of theta plus y prime cosine of theta. That's going to be x prime times sine of theta is 2 root 5 over 5 plus y prime cosine of theta is root 5 over 5. Factor out root 5 over 5. And we end up with 2x prime plus y prime. What I'm going to do now is create a huge mess, because what I'm going to do is in place of x, I'm going to put this, and in place of y, I'm going to put this into the equation that we were originally given. So here we go. Let me start creating this huge mess for us. What's going to end up happening is, here is my original equation, 4x squared minus 4xy plus y squared minus 8 root 5x minus 16 root 5y equals 0. So in place of every x, I put square root of 5 over 5 times the quantity x minus 2y prime. Wherever I see a y, I put square root of 5 over 5 times the quantity 2x prime plus y prime. And here's what I create. I have 4 square root of 5 over 5 times x prime minus 2y prime all squared. So that's like my 4x squared. Then I have minus 4x square root of 5 over 5 times x prime minus 2y prime times y, which is square root of 5 over 5, 2x prime plus y prime. Close paren, close paren. So that's the 4x squared minus 4xy. Then I have plus y squared. So I'm going to have square root of 5 over 5 times 2x prime plus y prime, all squared, minus 8 root 5 times x, which is square root of 5 over 5 times x prime minus 2y prime. Then minus 16 root 5, and in place of y, I have square root of 5 over 5 times 2x prime plus y prime. And that equals 0. So now what I have to do is multiply all this stuff out. So basically the situation is I have square root of 5 over 5 squared. So that would give me 5 over 25 or 1/5. Then you'd have to FOIL this. Then you'd have to FOIL this. FOIL this, distribute, distribute. Combine like terms. If you do all of that, and I'll just indicate that by 3 little dots, here's what you ultimately end up with. You end up with y prime squared equals 8x prime. You should recognize that this is the equation of a parabola. It's the equation of a parabola that's going to open to the right along the x prime axis. It's of the form y squared equals 4ax, so we have that a is 2. So the center of the parabola, or rather the vertex of the parabola, is at the origin with the focus lying a equals 2 units along the x prime axis. If we graph that equation, here's the result that we end up with. There's your vertex at the x prime axis, at the origin. This angle right here is the angle theta that we would obtain if we solved that equation. cotangent of 2 theta equals negative 3/4 way back at the beginning of the problem. Then I plot my vertex 2 units up along the x prime axis and draw in the graph of the parabola.